let's continue our discussion on prefix sums by generalizing it to a two-dimensional case. So instead of a one-dimensional array, given a 2D matrix, how can we find this sum of a submatrix? So for example, how would we find the sum of this square here? Again, if we think about the naive solution, we would just have to iterate through this small subarray, and if we have an n by m array, that would take O of n m times the number of queries. And of course, like the previous videos discussed, we can actually get this to n times n plus q. All right, so how do we do this? Well, a little bit of pre-processing work needs to be done. Let's use our previous ideas. So given this square, what can we say about its composition relative to the squares starting at the origin? Because that's essentially what prefix sums do, or maybe not the origin, but starting at either end. So if we notice, we can say, well, the first obvious one is this big, large square here. It starts from the origin. This is this little red square is included with this inside of this big blue square. However, again, as before, we have some extra squares we have to consider. Well, all of these highlighted in blue but not in red are extras that we need to subtract out. So how do we do that? Well, again, let's subtract out the squares that connect to the origin. So this green rectangle here, this is something we can subtract out, and then let's choose a different color. This orange rectangle would be subtracting out. So right now we have blue minus the green minus the orange, and this is supposed to be equal to red. And if you might have noticed at this point, if we were to subtract both green and orange, you see that green and orange themselves share this box here that I'm going to highlight in yellow. So this box here is essentially double counted when we subtract the two. So in order to remedy that, we'll have to add the yellow box. So this is the basis of our equations. And given that we do a pre-processing step, it's very similar to what we did before. So as usual, the origin is the same. And of course, the first row, really the procedure remains the same. You would just add the previous number. So this would be 9, 12, 17, 15. And then remember, at each endpoint here, we want to add all numbers in the square, including the origin. So for this 11 here, you'd add 7 to it, okay? And so for this 3 here, we need to add both 2, 11, and 7 for this little 2 by 2 square here. And so if we think about it, we would just add, we would just add them together to get the answer. All right, cool. Okay. And so on and so forth with the rest of the array. Now, let's move on to code. Actually, before we move on to code, there's something I overlooked. So if we cannot just simply add all of them together, since again, building this pre-processing array or matrix would take too long. So to find out this rectangle, we would just have to use the same trick we did with this slightly smaller rectangle, where we have the blue minus the green and orange plus the yellow. So if you think about it, basically 3, you would add 18 and 9. However, if you think about it, 18 and 9 basically double count 7 in its sum. So you would have to do 3 plus 18 plus 9 minus 7. So we have our N, M, and Q, and we read that in from standard in. Now, let's create our P-sum array. So call that n plus 1, m plus 1. Again, initialize it to 0. So let's iterate through. Yeah. So let's create a variable to read in from our entered in. And this is what, okay, if we bring up the rectangle again, let's just minimize this and have it as a reference side. We see that we need to add, or sorry, for the pre-sum, you need to add the current element that we just read in with the one on the top and to the left. And then we have to subtract out the double counted diagonal value. So let's do that. So ij would be, so the one on top. The one to the left. And then we have to finally subtract off the diagonal value. And of course, add the value that we just read in. Okay, so our processor or our pre-processing array should be done. And so now when we make the queries, we can simply, again, let's look back at our rectangle. We want to be the blue minus the green minus the orange plus the yellow. So remember, the queries are given by some numbers. Let's call them A, B, C, D. Read them in from the command line. And then we can just output the value that we get from using. Okay, so first of all, blue, it would be the lower right hand corner, which would be CD. Now we subtract the orange, which in this case, so maybe it would be easier for me to label them. So let's use purple. So this would be A, this would be B, this would be C, and this would be D. And so we can see that the orange would just be B minus 1 C. So let's do that first. Okay. And going back to this, we see that the green would just be A minus 1 and D. So let's do that. And finally, this yellow would just be A minus one, B minus one. So we actually have to add here. All right, and of course, end it with a new line character. Okay, so let's compile this. Okay, let's run it. I've already copied the input test case. So cool, 9839. And if we were to go back to the input 9839, and this matches. And again, as always, we can just submit this. And there we go. Well, thank you for watching, and I'll see you next time.